Let us continue ionic equilibrium. Now we will calculate pH for a 10 power minus 8 molar sodium hydroxide. Okay. Now I will take sodium hydroxide solution. This concentration is how much in the sense 10 to the power of minus 8 molar. Sodium hydroxide is a strong base, therefore it undergoes complete ionization. So concentration of hydroxide is equal to 10 power minus 8 molar. Now we will find H plus concentration in order to find pH. So Kw is equal to H plus into OH minus. Now we will substitute Kw, Kw is 10 power minus 14 equal to concentration of H plus into OH minus, we will substitute 10 power minus 8. From this we will find the concentration of H plus. Concentration of H plus equal to 10 power minus 6 molar. Let us substitute in pH formula. pH is equal to minus log of H plus. Substitute H plus concentration. So pH is equal to minus log of 10 power minus 6. Therefore pH is equal to 6. So we got pH of solution is 6. Okay. What is the solution given here? You see that we have got 10 power minus 8 molar sodium hydroxide solution. 10 power minus 8 molar sodium hydroxide solution is given. Sorry. Temperature is not mentioned. Temperature is not mentioned means we have to consider 25 degrees Celsius. We have to consider. Sir, at 25 degrees Celsius, pH is equal to 7 for neutral. pH is greater than 7 for basic. It is sodium hydroxide is a basic solution only, no? Sodium hydroxide is basic solution in the sense the pH of sodium hydroxide solution should be greater than 7. But how much here we are getting? We are getting 6. We are getting. That means we have committed mistake here. What is the mistake in the sense here sodium hydroxide concentration is very low here, 10 power minus 8 molar. When the concentration of sodium hydroxide is very low, what we have to do? Water contribution of hydroxide also we have to consider. Okay, water contribution of hydroxide also we have to consider. But when we are doing calculation for this one, for calcium hydroxide, pH we found. We considered hydroxide given by calcium hydroxide alone. Hydroxide given by calcium hydroxide alone we considered. Water contribution of hydroxide we have not considered because this concentration is not much very low. This concentration is not like 10 power minus 8. This concentration is not like 10 power minus 8. Therefore we have not considered water contribution of hydroxide. Okay, if the concentration of base is high, it is not much low, then water contribution of hydroxide we can neglect. Here concentration of base is very low, so water contribution of hydroxide we must consider. So that we have to consider water contribution of hydroxide. Sir, how to consider water contribution of hydroxide, that we will see. Now we will take a pure water. We will take first, we will take pure water. In pure water, what is the equilibrium is there? That equilibrium we will take H2O is in equilibrium with H plus plus OH minus. Here concentration of H plus is 10 power minus 7 molar. Concentration of hydroxide is 10 power minus 7 molar at 25 degrees Celsius. Now let us take this pure water 1 liter. Now to this let us add 10 power minus 8 moles of sodium hydroxide we will add. Okay. Therefore, in the resultant solution, sodium hydroxide concentration is 10 to the power of minus 8 molar. This sodium hydroxide is strong base which undergoes complete ionization to give hydroxide. So hydroxide contribution of sodium hydroxide is 10 power minus 8 molar. Now in the resultant solution, so and so equilibrium will be there. That means H2O is in equilibrium with H plus and OH minus. This equilibrium will be there. Now H plus contribution by water, we are saying that 10 power minus 7 molar as per this one. As per this one we said. Now hydroxide in the sense sodium hydroxide is contributing, and this water also contributing. We are saying. Okay, sir, concentration of hydroxide is this much. Now here we have taken this pure water. We have taken here pure water. We have taken in pure water, so and so equilibrium is there. This equilibrium is present. We are adding sodium hydroxide. Sodium hydroxide is giving common ion. What is the common ion? Hydroxide. Hydroxide is a common ion. Sodium hydroxide is giving hydroxide is a common ion. Therefore, due to common ion, what happens? Equilibrium is affecting. Equilibrium is affecting means equilibrium shifting towards favoring which side? Backward. So backward is favoring. Backward is favoring means H plus disappearing, suppose X amount. Hydroxide also disappearing, suppose X amount. So how much hydroxide remaining now in the sense 10 power minus 8 plus 10 power minus 7 minus X is the remaining. Then how much H plus is there means 10 power minus 7 minus X is the remaining. Now for this we will write equilibrium constant. We will write equilibrium constant. What we can say means Kw is equal to concentration of H plus into concentration of OH minus we can write. Now Kw will substitute 10 to the power of minus 14 into concentration of H plus we will write 10 power minus 7 minus X. Concentration of OH minus we will write 10 power minus 8 plus 10 power minus 7 minus X we will write. Now we can rewrite this 10 power minus 14 is equal to concentration of H plus into 10 to the power of minus 8 plus concentration of H plus. Like this we can write. Okay, now we are simplifying this one. We are getting concentration of H plus. We can get by simplifying this one. Sir. So we are getting concentration of H plus how much in the sense that is so concentration of H plus we are getting. From this we can go for pH. We can go. The pH is how much in the sense the pH is equal to here concentration of H plus we will write concentration of H plus is how much in the sense 10 power minus 14 by 10.512 into 10 to the power of minus 8. So concentration of H plus we got. Then we will go for pH. pH is equal to minus log of H plus. Let us substitute this H plus concentration. We can get pH. pH is equal to how much in the sense 7.022. Now see pH we got greater than 7. Okay, so why we got pH greater than 7? In the previous case we didn't get. Here we got pH is less than 7. Now we got pH greater than 7. Why? Because water contribution of hydroxide we have considered now. Okay, so when we have to consider water contribution of hydroxide, if the concentration of base is very low, if the concentration of base is very low, then water contribution we have to consider. If concentration of base is high, then water contribution we can neglect. Okay, so think that keep in mind that aqueous solution means water provides H plus and OH minus. Water providing H plus concentration, water providing OH minus concentration we have to consider. Okay, if it is negligible, you neglect it. If it is not negligible, you have to consider it. Okay, so if the concentration of HCl, suppose concentration of HCl given 10 power minus 7 molar, consider H plus contribution by water. If the concentration of HCl is 10 power 8 molar, consider contribution of H plus by water. Okay, sir. Next sum. Let us go to next sum. Okay, calculate H plus concentration and CHCl2 COO minus concentration in a solution that is a 0.01 molar HCl. 0.01 molar HCl and 0.01 molar in CHCl2 COOH. Sir. Now in the solution, what are the substances are there means HCl is present and CHCl2 COOH is present. Like this is present. So how to prepare this solution, that we will see. Okay, so now we will see, we will take pure water. We are taking pure water. We are taking pure water, the certain amount of pure water we are taking. In this pure water, what is the equilibrium is there means water is in equilibrium with H plus and OH minus. H plus concentration is 10 power minus 7 molar, OH minus concentration is 10 power minus 7 molar at 25 degrees Celsius. Temperature not given means consider 25 degrees Celsius. Now to this what you are adding in the sense pass 0.01 mole of HCl. Then add 0.01 mole of CHCl2COOH, dichloroacetic acid, and make the resultant solution. Here take the pure water such that resultant solution is 1 liter. Okay, So why we have to consider 1 liter in the sense for calculation easy, that's all. You can consider 2 liters also, you can consider. Based on that number of moles, you check it such that the concentration we have to get this much. How much concentration they have given, that much we have to get it. As per that you have to do it. Okay, now we'll see the concentration of HCl in the resultant solution. We have added 0.01 mole of HCl and we made volume of resultant solution 1 liter. Therefore concentration of HCl is 0.01 molar. HCl is strong acid, therefore it undergoes complete ionization to give H plus. So that therefore H plus contribution by HCl is a 0.01 molar, that means 10 power minus 2 molar. Now you say, shall we neglect contribution by water? Water contributing H plus, no? That concentration shall we neglect in the presence of HCl? Because in the pure water, concentration of H plus is 10 power minus 7 molar. Due to addition of HCl, what will happen? HCl will give H plus common ion. Due to common ion effect, here this equilibrium is making favoring backward. Backward is favoring in the sense water dissociation extent decreases. Therefore, water contribution of H plus still decreasing when compared to 10 power minus 7 molar. Therefore, water contribution of H plus we can neglect now by comparing with the H plus contribution by HCl. Okay, therefore water contribution we can neglect. Okay, H plus contribution by HCl is this much. Then we will take a dichloroacetic acid. We will take dichloroacetic acid, CHCl2COH, dichloroacetic acid. This dichloroacetic acid on dissociation gives CHCl2COO minus and H plus. Okay, this carboxylic group will give H plus. That carboxylic group is giving H plus, we can say. Okay, so what is the initial concentration of dichloroacetic acid? 0.01 molar. It will dissociate how much extent, means whether it is strong acid or not. You see here Ka value is given. Ka for dichloroacetic acid is how much in the sense 5 into 10 power minus 2. That means it is weak acid. Okay, therefore it is dissociating. Suppose X molar we will take, X molar dissociating. How much remaining means 0.01 minus X molar is remaining. Dichloroacetate ion is produced, how much means the X molar is produced. H plus how much present in the equilibrium in the resultant solution means HCl contribution and dichloroacetic acid contribution and water contribution. Water contribution is negligible, so we need not consider. Okay, this H plus means what? This H plus, this is called, this place is called concentration of H plus at equilibrium in resultant solution. Okay, resultant solution means concentration of H plus will be one value. We cannot say that this H plus is from HCl or it is from dichloroacetic acid. We cannot say. Concentration of H plus will be one value. Okay, therefore H plus contribution by HCl we are considering and H plus contribution by dichloroacetic acid we are considering. So H plus concentration at equilibrium in resultant solution is 0.01 plus X, we have to say set. So concentration of H plus we have written here. Set. Okay, now we have to find what we have to find in the sense X we have to find. For that case we will go for equilibrium constant. That means Ka is given, take Ka and in the Ka expression in the numerator write this right side thing, you write dichloroacetate and H plus you write. In the denominator you write this dichloroacetic acid you write in the denominator. Okay, so now we are writing Ka expression. Ka is equal to, in the numerator we are writing dichloroacetate ion and H plus concentration we are writing. In the denominator we are writing a dichloroacetic acid, we are writing dichloroacetic acid. Now let us substitute the values. Ka value how much given? You see that Ka value is given is 5 into 10 power minus 2 is given. So 5 into 10 power minus 2 will write. Dichloroacetate ion is X molar we said, and H plus concentration we said 0.01 molar, 0.01 molar plus X we said. Then concentration of dichloroacetic acid we said 0.01 minus X. Okay, here can we neglect this X? Can we neglect this X? Means don't neglect X, because equilibrium constant is 10 power minus 2. Therefore don't neglect X. Go for solving this via quadratic expression. So now we are getting a X value. We are solving this and we are getting X value. Okay, now we are solving this one and we are getting x value. X is equal to how much in the sense 0.7415 into 10 to the power of minus 2. X is equal to what we can say means dichloroacetate ion. Dichloroacetate ion we can say. Now we will go for concentration of H plus. Concentration of H plus we said 0.01, then plus X, 0.01 plus X. X value we are substituting 0.7415 into 10 to the power of minus 2. We are adding these two, we are getting H plus concentration. Therefore, H plus concentration is 1.7415 into 10 to the power of minus 2 molar. We got H plus concentration. Okay, sir. So what they are asking us to find, you see that they are asking us to find a concentration of H plus and a concentration of dichloroacetate ion. That's what we have calculated. Okay, sir. Next sum we will take. Now in this sum, now see this sum. A solution contains 0.09 molar HCl, 0.09 molar HCl, 0.09 molar dichloroacetic acid, and 0.1 molar acetic acid, 0.1 molar acetic acid. The pH of this solution is 1. pH of solution is given, that is 1. If Kf for acetic acid, is 10 power minus 5, calculate Kf for dichloroacetic acid. Dichloroacetic acid Ka value they are asking. They are asking us to find Ka value for dichloroacetic acid. So first we will take, now we are taking resultant solution. In resultant solution, what is the HCl is present, that concentration is how much in the sense 0.09 molar. It is giving H plus. H plus concentration is 0.09 molar. We cannot say. Why we cannot say in the sense that means concentration of H plus by HCl is 0.09 molar we can say, but anyhow we need not say, we need not come for this step, we need not come for this step. Okay, now we will say resultant solution. In resultant solution, concentration of H plus is equal to 10 power minus 1 molar we will say. Why? Because pH of solution is given how much, you see, pH of solution is 1 they have given. pH of solution is 1 means don't consider HCl. Okay, now consider resultant solution. In resultant solution, H plus concentration is 10 power minus 1 molar. That's what you consider. Okay, now dichloroacetic acid. Now for this dichloroacetic acid, they are asking Ka value. Therefore, dichloroacetic acid equilibrium we will write dichloroacetic acid CHCl2 COOH is in equilibrium with CHCl2 COO minus dichloroacetate ion and H plus ion. Okay, now dichloroacetic acid, what is the concentration given initially? That is 0.09 molar. So 0.09 molar dichloroacetic acid we are taking. It is dissociating how much in the sense X molar it is dissociating. So how much remaining means 0.09 minus X is remaining. Dichloroacetate ion how much produced means X molar produced. Concentration of H plus how much means write 10 power minus 1 molar. Don't write X. Don't consider HCl contribution, dichloroacetic acid contribution, acetic acid contribution, nothing you need not consider. Because they said pH of solution is 1. pH of solution is 1 is given, isn't it? So pH of solution 1 is given in the sense resultant solution H plus concentration is 10 power minus 1. That's all. Here this is H plus. This is what is the meaning of this? It is H plus. What is the meaning of this? Equilibrium concentration of H plus. It is called equilibrium concentration of H plus in the resultant solution, not dichloroacetic acid. Okay, this is called in this place what you have to write, equilibrium concentration of H plus in the resultant solution you must write. You should not say that it is from, this is from dichloroacetic acid. Okay, sir, this is called equilibrium concentration of H plus in the resultant solution only we have to say, sir. Okay, now we want what we want Ka for dichloroacetic acid. So Ka expression you write it, Ka for dichloroacetic acid, that expression you write it, Ka for dichloroacetic acid, Ka for dichloroacetic acid is equal to, in the numerator you write dichloroacetate ion and H plus you write, in the denominator you write dichloroacetic acid. In the denominator you are writing dichloroacetic acid you are writing. Okay, now we want Ka for dichloroacetic acid. That means we have to substitute these, we have to substitute now. Okay, these if you substitute, then only we can get Ka for dichloroacetic acid we can get. So we want Ka in the sense we must know X. If we know X, then only we can say Ka for dichloroacetic acid we can say. Therefore, how to get X? If you know X, if you know this X value, then only we can get Ka, no? Therefore, we want X. So, how to find X? That we will see. Now, concentration of H plus, we will see. Concentration of H plus in the resultant solution is equal to concentration of H plus provided by HCl plus concentration of H plus provided by dichloroacetic acid plus concentration of H plus provided by acetic acid plus concentration of H plus provided by water. These many things we have to consider, isn't it? Now, what is in the resultant solution? What and all is there? HCl is there or not? You have taken HCl, that will give H plus. Dichloroacetic acid we have taken, that will give H plus. Acetic acid we have taken, that will give H plus, isn't it? So everything is contributing H plus. So we have to consider all these things. So now we will write the dichloro now in the concentration of H plus in the resultant solution. Concentration of H plus in the resultant solution we know. Concentration of H plus in the resultant solution we know, that is how much means 10 to the power of minus 1 molar. Okay, so concentration of H plus in the resultant solution is equal to, first we have to substitute H plus concentration provided by HCl. HCl contributing H plus. Okay, HCl concentration is 0.09 molar. Therefore, HCl is contributing 0.09 molar H plus. Okay, so H plus contributing 0.09 molar H plus, then plus. Okay, now dichloroacetic acid contribution, H plus contribution by dichloroacetic acid, that is how much? This is a dichloroacetic acid dissociating X molar. Therefore, dichloroacetic acid is giving how much H plus? X molar H plus it is giving. Okay, dichloroacetic acid is giving X molar. Okay, then we have to consider H plus contribution by acetic acid. We have to consider acetic acid Ka value. We will see. Ka for acetic acid is 10 power minus 5 is given. That means acetic acid is dissociating to very much small extent. In the presence of HCl, HCl is giving common ion effect, HCl showing common ion effect. Therefore, acetic acid extent of dissociation still decreasing. Therefore, acetic acid contribution of H plus we can neglect when compared to HCl contribution of HCl. So, acetic acid contribution we are neglecting. Acetic acid itself we are neglecting, means what about water? We can neglect water also. Have we got idea? Sorry. So water contribution we are neglecting. Okay. So water need not worry. Acetic acid only. Acetic acid concentration. Acetic acid contributing H plus concentration we are neglecting. Why is it so? Because acetic acid Ka value is 10 power minus 5. That means for acetic acid, dissociation equilibrium is almost towards left. Now, HCl is contributing H plus. HCl is giving common ion H plus. Because of common ion effect, in this equilibrium is favoring still backward. Therefore, acetic acid dissociation is much decreased. So, concentration of H plus contributed by acetic acid is negligible. Okay, we have neglected that. Sir. So from this, the acetic acid contributing H plus we have neglected. Now we can calculate H plus. That means this X we can calculate. X is equal to 0.01 molar. Okay. So we got what in the sense X we got, that is 0.01 molar. Now we will go for Ka expression. This dichloroacetate ion is X, that is 0.01 molar we got. H plus is given in the sum, that is 0.1 molar is given. Concentration of H plus in the resultant solution is 0.1 molar given because pH is 1. Then in the denominator dichloroacetic acid concentration we will write that is 0.09 minus X. X is 0.01, that we will substitute. Therefore, we are getting Ka, we are getting now Ka is equal to how much in the sense 0.0125 Ka for dichlorostic acid. That's what they have asked. Let us go for next sum. Here, a solution of HCl as a pH 5. Okay, HCl solution pH is given, that is how much 5 is given. Okay, now concentration of HCl, pH is 5 in the sense concentration of H plus is equal to 10 power minus 5 molar. Okay, so pH is 5 means pH is equal to 5 means concentration of H plus is equal to 10 power minus 5 molar. Okay, sir, which is equal to concentration of HCl. So we know concentration of HCl. Okay, here pH is 5 is given, therefore we have written concentration of H plus is equal to 10 power minus 5 molar. We have written this is equal to concentration of HCl, we can say. Okay, then second statement, if 1 ml of it is diluted, diluted means what? Addition of solvent, here addition of water. Okay, solvent is not mentioned means you can consider water. Diluted to 1 liter, that means 1 ml of this solution you are taking 1 ml of this solution, to this you are adding water and making the solution to what? 1 liter. That means you are doing dilution. Okay, sir, now we will take a dilution law, we will take. Okay, dilution law in the now we will see number of moles of HCl before dilution, we will see, and number of moles of HCl after dilution, we'll see. After dilution. Okay, now you consider number of moles of HCl before dilution and consider number of moles of HCl after dilution. Now you say dilution law means you are adding only water, you are adding solvent, you are not adding no, you are not adding solute. Therefore number of moles of HCl before dilution and after dilution, how it will be there? They will be equal. Why? Because we are diluting here. Dilution means what? Addition of solvent, addition of water. We are not adding HCl. Therefore number of moles of HCl before dilution and number of moles of HCl after dilution, how it should be there? They must be equal. Okay, set number of moles is equal to volume into molarity. If you multiply volume of solution and molarity of solution, you will get number of moles. Okay, provided volume should be in liters. Okay, volume of solution you take in liters, multiply with molarity, you will get number of moles. Then here volume of solution you take in liters and multiply with the molarity of solution, you will get number of moles. Okay, so dilution law means v1 m1 is equal to v2 m2, we can say. Sir, now v1 is how much we are taking? 1 ml we are taking, that convert into liter, so 10 power minus 3 liter into molarity. Molarity of HCl how much here? 10 power minus 5 molar. So 10 power minus 5 molar we are substituting. Then v2 is how much? V2 is 1 liter. V2 is how much? 1 liter. 1 liter we are substituting, we are calculating molarity. Therefore molarity after dilution, we got molarity after dilution, that means concentration of HCl after dilution, how much in the sense 10 power minus 8 molar. So we got concentration of HCl after dilution, we got, this will give concentration of H plus. So we got concentration of H plus after dilution. Sorry, after dilution concentration of H plus by HCl is 10 power minus 8 molar. Now what is the pH of solution they are asking? Okay, they are asking what is the pH of solution? How much shall we say? Shall we say pH is 8? Okay, so after dilution, what is the pH they are asking? So now we have to find the pH, we have to find. Okay, so after dilution, in the sense concentration of HCl we got 10 power minus 8 molar. Okay, therefore concentration of H plus in the resultant solution is equal to concentration of H plus by HCl after dilution. Then we have to consider even water also, concentration of H plus provided by water also consider. Okay, so HCl contributing how much? H plus means 10 power minus 8 molar, we said. After dilution we got 10 power 8 mol minus 8 molar. Okay, so water contribution also you must consider. Why? Because HCl is HCl concentration now is much low. HCl concentration now is much low. Therefore, water contribution also you have to consider. Okay, sir. Water contribution of H plus is X molar we will consider. Okay, because common ion effect will be there. No, so water contribution of H plus is X molar we have considered. Okay, now we have to go for equilibrium. What is the equilibrium? Means water is in equilibrium with H plus and OH minus. Now H plus concentration is how much? Means 10 power minus 8 plus X molar we have to write at equilibrium. In the equilibrium, okay, in the resultant solution, after dilution, concentration of H plus is 10 power minus 8 plus X. 10 power minus 8 is contributed by HCl, X molar is contributed by water in the new equilibrium. Okay, now what is the concentration of OH minus in the new equilibrium? We can say X molar, we can say. Why do you say X molar? Because water contribution of H plus is X molar, means water is contributing how much H plus, that much OH minus only water can contribute. No, X molar H plus is contributed by water. Therefore, the same amount of OH minus will be contributed by water. Okay, now we will take equilibrium constant, that is Kw is equal to concentration of H plus into concentration of OH minus. We can say Kw is equal to 10 to the power of minus 14. H plus concentration is 10 power minus 8 plus X. OH minus concentration is X molar. Set. So we have substituted everything. From this, what we can calculate in the sense H plus concentration, we can calculate X. From X we can go for H plus concentration, then we can go for pH. pH how much we are getting in the sense 6.978 we are getting for this. Okay, so like this we are calculating pH. Okay, here water contribution of H plus we have considered because HCl concentration is much low. Okay, water contribution is not negligible when compared to HCl contribution. Therefore, water contribution we have considered. Okay, so next we will go for this sum. Calculate the pH of solution obtained by mixing 10 ml of 0.1 molar HCl and 40 ml of 0.2 molar sulfuric acid. So now we will take a 10 ml of 0.1 molar HCl. We will take 10 ml of 0.1 molar HCl we have taken. Let us multiply volume and molarity. We will get millimoles of HCl we will get. So we got millimoles of HCl we got. Okay, sir. Next, to this we are adding what in the sense 40 ml of 0.2 molar sulfuric acid we are adding. Now we will multiply this volume 40 ml and concentration 0.2 molar. We will get millimoles of sulfuric acid. We will get how many millimoles? Means 8 millimoles of sulfuric acid we are getting. We have got 8 millimoles of sulfuric acid. Sir, now this HCl on dissociating completely, it will give 1 millimole of H plus ions. HCl on complete dissociation gives 1 millimole of H plus ions. Sulfuric acid, we will consider complete dissociation, we will consider, because regarding that nothing is mentioned, therefore complete dissociation we will consider how much H plus ions it will give. Means 16 millimoles of H plus ions it will give, and how many millimoles of sulfate in the sense 8 millimoles of sulfate ions. We are not considering bisulfate. Bisulfate also undergoing complete ionization. Like this we are considering. Okay, so sulfuric acid we are considering the dissociation to what in the sense H plus and sulfate. Like this we are considering. So sulfuric acid is giving 16 millimoles of H plus ions, we said. Now we will take resultant solution. In the resultant solution, what is the volume in the sense 50 ml is the volume. Why 50 ml? Because HCl is 10 ml and sulfuric acid is 40 ml. Therefore, resultant solution volume is how much? 50 ml we can say. Then in the resultant solution, how much H plus ions are present? Why we are considering H plus ions? Means we want to calculate pH of the solution. So we are considering H plus ions. Here 1 millimole is present. Here 16 millimole is present. Therefore 17 millimoles of H plus ions present in the resultant solution. So now we will calculate concentration of H plus. Concentration of H plus is equal to this 17 millimoles of H plus ions by this 50 ml volume of resultant solution. So from this we will get a concentration of H plus. So concentration of H plus we got this much. From this we will go for pH. pH is equal to, now pH is equal to what we can say, means minus log of H plus concentration. So we'll substitute minus log of H plus concentration is 0.34 molar. We have substituted this minus. We will take we are taking log for this. Log for this means point is there, means here point is there. Therefore, we have to keep 1 bar. We have to keep for 34. We are taking log for 34. What is the log in the sense? 5215 is there. Now let us take minus inside. This minus into 1 bar means it is minus 1. Minus 1 into minus is called plus 1. We will write then this 0.5215 is positive term. This 0.5215 is positive term here. This with the minus will get minus 0.5215. Okay, this is 1 bar means it is minus 1. This 0.5215 is positive term. This positive term with this negative sign will get minus 0.5215. We will get now we are subtracting. We are getting pH of solution, that is 0.4685. So we got pH of solution how much in the sense 0.4685 we got for this case. Okay, so for this we have found pH. We have found. Next we are going for next sum. Here what is given means what is the pH of 1 molar solution of acetic acid. So for acetic acid solution, what is the pH? Okay, here Ka for acetic acid is given 1.8 into 10 power minus 5. Okay, so Ka for acetic acid is given. Now they are asking us to find a pH. They are asking us to find. Okay, we can calculate. Okay, so now we are calculating acetic acid is dissociating to give what in the sense acetate ion and H plus ion. Okay, what is the concentration of acetic acid given? 1 molar given. Acetic acid is weak acid, so dissociating X molar. How much remaining? 1 minus X molar is remaining. Okay, now acetate ion how much produced? X molar produced. H plus how much produced? X molar produced. Now we'll take acid dissociation constant. Ka for acetic acid is equal to, in the numerator what we can write in the sense acetate ion we can write and H plus we can write. In the denominator what we can write means acetic acid we can write. In the denominator we have taken acetic acid. Now Ka value will substitute 1.8 into 10 to the power of minus 5 we have substituted. Acetate ion is how much means X, H plus is how much means X, acetic acid is 1 minus X. Now shall we go for approximation or we need not go for approximation? Yes, we can go for approximation. 1 minus X we can nearly take it as 1. X we can neglect when compared to 1. And also Ka value is 10 power minus 5. So we are neglecting X when compared to 1 we are neglecting. So we are getting 1.8 into 10 to the power of minus 5 is equal to X square. Now we are simplifying this. We can get X value, we can get X is equal to concentration of H plus, that is equal to concentration of H plus is equal to 4.24 into 10 power minus 3. So we got concentration of H plus. This value will substitute in the pH formula. In the pH formula, if we substitute, we will get pH how much in the sense 2.3724. So we got pH of solution. Okay, so pH of solution is how much means this much. Concentration of H plus how much means? Okay, now the first subdivision we have completed. Second subdivision will go. Now second sentence we are seeing, to what volume 1 liter of this solution be diluted? Diluted means addition of solvent. Solvent is water here. Okay, diluted, so that pH of resulting solution will be twice of original value. That means we are diluting this solution. This solution pH, what happens?